To welcome our first lecture for the day, and his talk about algorithms automated the separate tasks of general physics.
Yeah, hello, my name Ignat. I was working in Moscow Institute of Electronic Techniques and some another university, and I was used last 8 years metodic for represented physical role for my students. And second reason that I make the script is make a better library for present and to make articles about physics. And reason number 3, make something more simple and more fun for children for study physics with interface similar with Minecraft. That is part of physical quantities, and let's look to just some selected quantities inside of the table. So everybody will imagine some bricks, solid bricks, and solid bricks have geometrical size, length, width, and height. And if we look to that is 3 cell, it's exactly what about I told. So if we multiplicate length to width, we will have square, and next operation give to us volume. So it's simple represented. But if we look to back direction from volume to the angle, we will thinking about the same segments like cohomology chain, and in 3-dimensional represented, it's just cell with volume, but cell between each other have square, and square goes through the segment of white, and we will continue this cohomology cell to chain to the negative part. And to find physical role inside of table, just need to find track or way between one equation to one cell with physical quantities to another cell with physical quantities. For that, I will use a simple wave algorithm. So how work wave algorithm? You will see on the illustration. It's some Python Minecraft script, whereas we see how wave start from this point, go through the structure, have some small perturbation near the turns, and cover full structure. Approximately the same way, we will find physical role inside of physical quantities. And if you will look to GitHub, you will find the source code. It's made on the Perl 8 years ago. And by this, but I put to open source just 3-5 days ago, the script. So that is slide about different coordinate system. Usual in young school, we will use it linear coordinate system, but possible use cylinder or spherical coordinate system. This slide about torus. So, and you will see how what kind of formulas we have for surface and volume of the tor, and diameter of the tor. So I don't want to speak about details, but if some people interested about mathematics, you know these formulas. Let's look one more relation that connected to the time. So look to the length. It's here, speed, and accelerate. by multiplicated or by derivation to the time, we will see the equation for motion of material point. I mean, just you have coordinates. If you multiplicate speed to time, you will get again coordinates. If you multiplicate accelerate to time in the square, you will have a full equation for move a motion point. So, and for better use the system, we put the operation number upstairs, and time we keep inside of the table, and time have both direction, like multiplication, derivation, and some physical constant we will move to another part of the table. So this simple model enough for young school and simple physical problem possible solved, just put parameter inside of the script. How it's work? For example, for this problem we will have a volume of the oil over the water, and we will have a square of the oil over the water, and for us need find the diameter of molecule, and we think that layer of the oil is just equal 1 diameters. So we just take script, put parameters, push button, and we'll have formulas. So, and because Perl work like backend, and 8 years ago it was the same, I don't have good front end, but by CGI model I will have this result, and you will see any parameters, you will see a physical constant, and you will see operation related with spaces like number. So the same way I will, after generated probably most of any physical law, basic physical law, it's about 100 that engineers use it on his practice. And any this law you will find, for example, in my repository, there is some place where is in text file you will find any laws, and exactly from this script. So another more complicated example, it's Maxwell Heaviside Ampere equation. And that is, you will see diagram of Deschamps. It was made in 1986, and before engineer Kron from General Electric from America in 1932 makes the similar algebraic topology diagram for physical law. So, and of course now it's a part of the table. Later you will see where is on the table we have this diagram. And the same system we will use for more complicated example for nonlinear system. And any operations that you will see on the slide, like Wedge product, Hodge star operation inside of the table. And it's just simple example about a cohomology sequence that we were speaking before. I don't want all details. So it's a final view of the table. There, physical constant. That is a space operation. And from this side, I think better maybe look to first slide because it's English. So any horizontal line related to some part of physics, for example, that is horizontal line is electrostatic, that is magnetostatic, and that is with elastic. And if we connect it together, magnetostatic, electrostatic, we will get electrodynamics. What it's Greg explained by Maxwell equation. So let's look to example from the library make it on the Python. It's called SymPy, and inside of library there is special module for geometric algebra, and I think it's most advanced library that we have now on the scripting languages, and possible at the same time with Perl improve this kind of library, because when the person make, for example, equation or program for Maxwell equation, he must select metrics by yourself. He must select relation with a geometric algebra for electromagnetics, and he must select some number operation. By the way that I explained it, possible do this reselection automatical, because inside of the system we have a lot of symmetry. For example, that is line, any symmetric cell, if you multiplicate, you will have force. And you will have sequence of differential form related with vertical column. So for example, if we have near the force, this column, it's zero form, and next step, that is one form, and after that we have 2, 3, and again 2, 3. So it means just number operation that we will use it for any cell from this vertical column, give to us gradient. And next number operation give to us rotor, and next divergence. So a lot of symmetry, and you will make selection related with mathematics automatical. Don't need to choose from the head. So result of this script you will see on the screen, and that is part of equation for Maxwell equation without coordinate. But in coordinate form it will look like that. And by SymPy we will automatically find 4 roots, and we will interpret this result like some solution inside of Riemann square. Riemann space, sorry. So that is part of the same equation on the table. I mean, when we make a sum that is matrix and that is transparent matrix, we will have exactly that is for cell. And if we added it to this for cell, source of electric and magnetic source and time connection, we will have full system of the Maxwell, and it's probably the same place what I told about diagram of Deschamps or algebra topology diagram from Cron. And another good point, if you take a symmetry part of the table, we will use the same system for equation for kinetostatic. So by this table, very similar with multiplicate table, possible make research and possible very advanced read of physical articles. And that is some example. I just see some algorithm how people do his articles. So it's all. If you have some question, I will ready to answer. Thank you for your attention.
Does anybody have any questions?
How it is implemented in Perl? It is some way does symbolic computations, or it is hard-coded that table
Yeah.
in Perl?
Yeah. In Perl, it's if you go to GitHub repository, you will see Perl script. But if told just few words, we have a big hash, and any hash have array related with electrostatic, and inside array we have some cell quantities and operation, like number of operation, quantities and operation. And after that, when we selected two cell, we try use wave algorithm. Wave algorithm work like, for example, you put one here, and next step you added it to any cell around some point. So next step of algorithm, this cell have index 2, and cell around have index 1. So it's continuous, it goes through the full system. And when the wave go back, we will have a shortest way. And after that, we connected operation and make simplification of this operation and have a result formula. If you have 2 or 3 parameters, we make some optimization. But optimization related with coordinate system and with selected model. I told, I hope I will support 4 coordinate system: linear, cylinder, spherical, and torus. Do you have another question?
This hash that you have has mappings, not mappings, arrows from one equation to another. Am I assuming right here? Mappings from one equation to another inside this hash you just described.
Mapping, maybe you told me some solid example. What do you mean exactly? Mapping, just to try to out, no problem.
You get from one equation to another inside this hash.
We have in the hash full table, and inside of the script it's like map of the cell, that any cell have a chain of relation. And
how do you generate this mapping from one to another, or do you manually draw?
I put full table inside of the script. You will see in repository, and when I put parameters, here, the same time script selected some physical equation. And here, for example, we would like find a geometrical size like length, but we will have a square and a volume. So first we find way from the volume to length, and after that we find way from the square to length. So we'll have to chain. And after that we make optimization. For example, if we one step make multiplication, next step derivation for the same, so we take out this. We make a chain shorter. And after that, when we have two chain, we will make, for example, sum or some combination of this related with coordinate system. I don't know if you look the script, because I put to open source, you will see some details. Or maybe later, if you want, I will show on my computer.
We don't have any more time, so this discussion could proceed in the short break we'll have right now. Let's thank our lecturer again.
Thank you.